today we're going to try and do this instead of a traditional death by PowerPoint, but an actual conversation with real people driving real networks and find out how they actually went about doing open networking in SDN. So I'm Paul Unbehagen. I joined Big Switch just this year, January 2nd, as the CTO for many of the technologies you're going to see and hear about today. And we're going to talk about a lot of interesting technologies, but for us at Big Switch, it's been a very interesting week. We actually announced the OEM with Dell, so that many of the technologies that you're going to see today, you can actually get through Dell very easy to be able to do yourself and build your own clouds. Now, on the panel, we have some interesting set of collection of industry. We have an auto manufacturer doing some pretty cool things with electric vehicles. We have a very large consumer payment processing company that shall not be named, as the joke goes. And then we have a interesting collection, too, of transportation. Transportation and railways in ways that will probably surprise you because they completely surprise me in how innovative they are. A train company that's 150 years old, that's probably one of the most innovative out there. An electric vehicle company that's also insanely innovative in how they go about building their own data centers. Now, in the financial space, insurance and payment processing have a lot of things in common as well, so we'll talk about that, how they go about building their own clouds, and how they're using open networking to do that, and how it's benefited them in ways you probably wouldn't realize, compared to a proprietary closed-end system, things like sparing and other ways you can build out your architecture. So what I want to start on real quick is a description of background of how we approach things at Big Switch. So at Big Switch, we build a networking and monitoring solutions for the data center. We're a software-based company that builds the OSs that run on Dell's open hardware. So you can buy Dell-only switches that run our software to build a full, complete, true cloud solution, the same style as Amazon. So we believe that in a strong way in many different cases, but in particular because applications have an affinity to be in certain locations, either up in someone else's cloud or somewhere in your private cloud. And there's a lot of issues with shadow IT and other issues in the way in which we built data centers over the last 30 years. And I'll say that as being one of the people who are behind standardizing on these protocols. So I have around 50 patents and different routing protocols from ISIS, the BGP, the MPLS. I've been a standards member for 20 years and voting members of .1 and IETF. And so I was one of the people creating all the problems in the background. But when you think about how the cloud providers built their data centers, they did not take old protocols and old switches and a campus solution, slap a data center name on it, and then say it's ready for cloud. If you look at how all of them operate, they operate on an SDN-based approach using open networking. So everything that you're going to hear today from these enterprises are actually the same thing that you see in AWS, Google, PayPal, Facebook. So it's not a matter of, is this technology ready for the mainstream? It's already in the mainstream. It surrounds us all every day. And it's growing at a very fast rate. So that becomes a very interesting piece of this. And how does that apply to the affinity of this is that there are things you should build that are strategic to you, and there are things that you should never build again because they're commodity. As a natural evolution of all technology, that kind of affects where you build out a cloud. From this perspective, we don't believe cloud is a location. Cloud is a set of principles that should drive a new design paradigm for a better data center. So if you're building out a data center, you should actually take the same principles that the cloud providers use and build them on-prem. So that way you have one consistent experience from end to end. Because up to now, most of the areas of the data center have evolved appropriately. They've grown to the right compute level, they've grown the storage level, but what hasn't actually kept up is networking. And for the longest time in networking, we were the innovators in many IT departments. What happened along the way is we started to become the laggards. And that's the reason why you see things like the Clean Slate Labs and a few other places where they had to start from a clean slate, hence the Clean Slate Lab name, to start and actually create a new way of building out cloud data centers. And that leads to a different perspective of how you do that, because up to now, those applications are shackled in data centers using traditional models of VLAN and VRF. When we invented VLANs and VRF, they were never meant for the idea of mobility and services. VPCs, though, which is what was born out of the AWS labs in that approach, are. Their entire intent in creation was to be mobile, adaptable, and easily movable. And they're self-contained mini data center, hence why they're called a virtual private cloud. And in many enterprises, they'll use that as a way of saying each application can have its own VPC. groups can have in VPC, any combination that you might need. That gives an unshackling to the apps to move wherever they need to go. Now, doing that is one thing is building, but you actually have to provide real visibility. Why are packets moving, where are they moving, and what are they being moved for? So that's the whole approach of doing this in a cloud perspective. So you want to basically have the same approach as the same providers and hyperscalers are able to do to have the benefit of what's being done in enterprise, have one consistent experience, and then you get a whole lot of interesting plays out of that. There's only one way to do that when you do it from the software-defined function. You don't recreate a campus network and call it a data center solution. Open hardware allows us to do a lot of interesting things too from a cost basis. Because we can use the same commodity hardware that Google is, we get a lot of economic cost benefits there. Economies of scale as a benefit. And integrating analytics using the same chips that we have in many of the other places in the world allows us to actually see individual flows, but also redirect flows, but not have to do it in monolithic chassis. We can distribute it across a data center or many different data centers and grow it out and manage it individually or as a collection of units. That allows some pretty interesting things as well. Now, one way to look at this thing is, at Big Switch, we call this approach cloud-first networking. That is, if you're going to build a data center for the next generation, you shouldn't take that old approach. You should take a cloud approach to building data centers. You don't see the cloud providers trying to build the same solutions that we do at campus. So why would we take that approach and run our on-prem data centers the way we run our campuses? We should actually run the on-prem data centers the same way that the cloud providers that we put our apps up in the cloud do. So that would be the infrastructure piece. Build a network the same way that the public cloud providers did so you can get the same benefits. That way you can provide exactly the same consistent set of services on-prem that your customers or the application guys or the actual customers using the application can expect. It allows the applications to balance out equally across the equilibrium of what is cloud, private cloud, hybrid cloud, or public. And then that creates a nice consistent experience for your operations teams as well. You get a nice balance of the way they approach it. Whether or not they have VPCs up in their public cloud or VPCs down in private cloud, that model allows them to approach the problem as the same consistent model going forward, making it really easy to troubleshoot things. Another benefit of having those analytics and built in from a monitoring perspective is that you're now able to see exactly what's going on in the environment. So this marriage of seeing both the network and the virtual at the same time gives visibility to both teams to collaborate a lot better. And that's another benefit that you'll hear about as well as we jump into this in a second. So I'm going to jump off the stage a bit because I plowed through that here and hand it over to Scott to talk about how you're doing things in American Dell, because you have a very interesting story about a brownfield data center.
Yeah.
Go ahead and take it.
All right, so I'm Scott Miller. I'm a technical infrastructure engineer for American Fidelity. And so our journey with Big Switch starts back in 2013 when we purchased a new campus. We had the opportunity at that point to go ahead and build a data center from scratch. Our old data center had been built in the 1960s, housed our original mainframe, and we've kind of just kept tacking things onto it ever since. Cable management was an absolute horror. There were racks everywhere. It was on a raised floor, and when we moved out of there, we found rats living underneath our data center. So that was very interesting. So we had a long-standing good relationship with Dell, and we had reached out to Dell to kind of see, at that point, kind of what's new. We, as a company, have had kind of a top-down approach to try to be as innovative in our space as we can be. So we reached out to Dell, and they introduced us to Big Switch. We kind of took a step back and said, this is very different than anything we had seen at the time. We, of course, reached out to several other vendors, did several POCs, but one of the things that struck us out as being different with Big Switch was that we had the Big Switch environment up and running in a single day, with things racked, we were passing packets, building policies, and it was very much easier than any of the others that we were looking at. So they won us over pretty quickly. So from that mentality, we went ahead and moved forward, built out our data center around Big Switch, and from there, We deployed a spine leaf architecture, kind of getting away. The old data center was built as part of a collapsed core. So as a part of this, one of the things that we absolutely loved that kind of related but not is just simple pieces of cable management. The idea of having a big switch, any port can be a part of any network, and we don't have to run cables all across the data center. It's much easier to manage. The manpower it takes to keep that running is much less than we ever had to use before. We have several sister companies, and the ability to leverage tenants, basically the VPCs, to keep things separated. So if we have a sister company that has needs, they can leverage our data center, they can put their environment in there, we can spin things up, keep it completely separate from our own environments. We also have a big push within the company. We do disaster recovery tests. So we have another entire tenant that we will just restore all of our production environment into this isolated tenant to do disaster recovery testing, which as a company has basically enabled us anytime anything goes down, we know that we're ready for it. We're based out of Oklahoma City. We all know what Oklahoma is well known for. There's lots of tornadoes. So being able to sustain that and know that we're protected against those things has been excellent. I don't think.
How did you go about doing your pod when you came into it? That was an interesting kind of story as well. When you were preparing that out, how long did it take you to actually get that running?
So it was a single day. We had things up and running. Yeah. We enjoyed the big switch aspect of it because of its simplicity. Our team does everything. So the manpower it takes to run them, we didn't want a solution that was going to require constant care and feeding to make sure everything was running properly. It just works, which is excellent.
How big is the team that's running this?
There's two of us that run the big switch environment.
Two, nice. And analytics or anything like that, how do you go about that? So
we leverage the analytics pieces. We're actually in the midst of a POC with that we're fixing to move forward with purchasing. But the pieces that allow us to, everything is virtualized. So getting insight into the traffic that's flowing within these VMs is very difficult. So the analytics pieces that allow us to span straight from the VMs into this environment to get insights into the actual packet flows within the virtual environment is awesome.
Nice. Where do you plan to go in the future with the environment?
So next, we have definitely a cloud, an actual public cloud environment that is slowly growing. So the analytics pieces are probably what's going to be moving there first. The monitoring fabric, stuff like that, to actually get an insight what's happening in the cloud.
Nice. So, is there anything else you want to share? Or?
I think that will cover it.
All right. So we'll go ahead and hand off to John here. And John, you have a very interesting environment that all of us care very deeply about. It can ruin Christmas, I suppose it doesn't. We can't even get our coffee. But what I find interesting about your environment is your network is the service, is the business, right? And you got to deal with some because you're a very interesting target for a lot of bad people. Right? So visibility becomes a very interesting part for you, right? I'll go ahead and, sorry, there you go.
Okay, thanks, Paul.
Yep.
So, my name is John Clouatre. I've been working in the networking industry for about 15 years, different roles, operations engineering, and most recently in the data center network engineering team at one of the largest global payment processing companies. And basically, our product is to connect consumers, businesses, banks, governments together and enable financial transactions. When most consumers think about our products, it's the piece of plastic in your wallet, right? But as Paul said, it's the product is really our network, right? That's enabling all this to happen. And our network, to give you kind of a little bit of context, on an average day, we will settle over $10 billion worth of financial transactions. And so we have very strict availability targets that we work towards. Specifically internally, our service levels are set at 6 nines, which is basically 30 seconds of downtime over an entire year. And I mean, that 30 seconds, when you're talking about billions of dollars on average every day, that could be significant loss of revenue for us and penalties that we'd have to pay to our customers in breach service levels. So availability is a significant concern for us. I guess in parallel, security is also very important. So to give you an idea there, over the last quarter, we had around 350 million different security incidents related to our network. That could be anything from a DDoS attack to malware infection or like a phishing attempt, right? A lot of different things. And so to kind of achieve these targets that we're setting and meet these security requirements, we need visibility into our network, right? We need to know what's happening there and be able to react when there's incidents or things that are happening. And so one of the kind of key ways that we provide that visibility is through something called a network packet broker, which isn't really a familiar term for most people. So I'll talk a little bit about what that is. Basically, it's a parallel network to our production where we have connectivity out from network devices, switches and routers, and then actual physical tap devices that feed into this network packet broker network, where we can then perform different filtering or manipulation functions on that set of traffic, specific to the requirements that we have for different network monitoring and security monitoring tools that are attached, right, on the backside. So to give you an idea what kind of manipulation stuff we do, what does that mean? We have some like network and security alerting systems that are attached there, IDS, right? And it's feeding these packets in. We need to deduplicate those packets. Otherwise, we have a situation where we'll be generating a bunch of noise in our alerting system for operations, right? So this deduplication function that we can perform in the packet broker will significantly increase our effectiveness in addressing any kind of alerts that come in. One of the other things that we do with regards to packet manipulation is we have obviously a lot of sensitive information that's passing through this network. And in some cases, we have specific requirements, mandated requirements that we either need to drop the entire payload and we can just send the header across, metadata basically, for these monitoring systems, or we can actually go into the packets and use a masking function to find that sensitive information and basically redact it, right, from the packet and then pass it along. So that's kind of how we use this network packet broker. And we've been doing this a long time, right? We've been using this for a long time. And up until about 3 years ago, what that solution looked like for us was a monolithic modular chassis, right? Multiple monolithic modular chassis, right, in our data center. And those chassis were obviously running proprietary software. They were expensive to maintain. And we were reaching a point where we couldn't really scale that effectively any longer because of the actual resource constraints we're running into in the data center. The number of ports we're talking about on these packet brokers is thousands, right? So it's a lot of connections, and the power, the cooling, the cabling infrastructure requirements, it was not easy to grow this thing. We were at a point where we needed a different solution. And so we started looking at distributed solutions, moving away from a centralized architecture. And around the same time, we actually were going through a similar exercise on our production networks. To Scott's point, we're in the same place that they were, right, with a 3-tier collapsed core model, using these modular chassis, and the access layer we're running, fixed chassis, but it's running custom ASICs. And we were looking to shift to a spine leaf model with fixed chassis across the board using disaggregated, right? So disaggregating the hardware and software, giving us the flexibility to choose, right? Choose our own destiny. And so we wanted to apply those same principles we're looking at for production onto this packet broker infrastructure. And we went out into the market to look at what vendors had to offer. And there really wasn't anything available outside of Big Switch that met all those requirements that we had. And so, those requirements specifically being that we're looking for a distributed solution with a disaggregated hardware and software model. We needed something that had feature parity with our other solution when I'm talking about those packet manipulation functions. And then it needed to be cost effective too. So again, we had a good partnership with Dell already, and identified them as our hardware provider, and then using Big Switch as that software layer, we were able to really kind of fit exactly what we needed in an effective way. And specifically, talking about cost, right? When we put the business case together and we broke it down, we saw that compared to our previous solution, our incumbent solution, the per port cost was about 50% less using this. And so our management was very excited about this, obviously. The other benefit that we saw is when you're looking at going from a centralized to a distributed architecture, one of the drawbacks is that you're also distributing your management plane, right? So now you have, previously a handful of devices that are centralized. Now you have potentially hundreds of devices distributed that you need to operate and manage. And Big Switch is able to kind of elegantly solve that problem using the software-defined controller, where you can still take advantage of the distributed architecture, but you have a central control plane there. So for operations, that's a huge win. Actually, it's even better than what we had with the centralized architecture, because it was still multiple chassis that are managed box by box. This is just a single controller, it manages the entire fabric for the data center. Extending that further, we're talking about multiple data centers around the globe, and Big Switch released a multi-cloud director, which is basically a controller of controllers, and that gives us a single kind of view into all of our global deployments. For our operations team, that was a huge win, right? For engineering, the thing that we really enjoyed is specifically the disaggregation, right? Because with our newer data centers now that we're building, what we're able to do is leverage the Dell hardware single SKU, right? Single hardware platform in our network packet broker infrastructure, running Big Switch software, and then in our production network, running a different network operating system, the same piece of hardware. And thinking about this from previously, having a huge variation in different hardware we're using for different roles in the network, that now we have basically a single platform. We don't need to worry so much about having high touch support, 4-hour RMAs. We can just buy some spares, and that's covering us. So all that said, that's kind of where we're at now, and what we're looking at kind of moving forward is some of these additional kind of product set that integrate in with the big monitoring fabric, the packet broker, the analytics nodes, and the recorder nodes. And trying to see if we can achieve similar efficiency gains and cost gains, or cost reductions, I should say, with those appliances, which we think is a great option. So.
Anything else you want to add? How's your path been, your journey on this?
It's been easy. No, to Scott's point, you go into the data center, you connect everything up into the management network, you turn on the controllers, and you throw some minimal configuration in, and then everything comes up. You have your policies, but it's, yeah, from a management perspective and a deployment perspective, the first data center that we deployed, it was less than a day that we had this thing up and running. So it's very easy.
No more network maps, no more having what port was what plugged into,
No.
it just automatically discovers it.
Yep, it's
Nice.
magic.
Thanks,
Something
John.
like that.
All right. So, they only gave us 2 mics, so we're having to hand off to each person here. So Michael's going to talk to us about a very unique environment with one of the most interesting approaches to actually doing a real container environment. I'm really excited to actually hear it. But also, I like what you're going to go through here in a minute with and here's a clicker, about what is Neo and what do you make and how does that generate a tremendous amount of data and how do you manage that in that environment? So you had to build something from scratch.
We did. Thank you, Paul.
Yep.
I'm Michael Richmond, Principal Architect for the Autonomous Cloud and Systems Platform at Neo. Neo's an electric car company based out of China, but we have offices in San Jose, Munich, and London. Some of you may have noticed us or be aware of us because we had a segment on 60 Minutes back in March highlighting Neo as one of the new EV companies coming out of China. Neo was founded about 5 years ago by William Lee. William Lee is a serial entrepreneur, and he was looking at the skies around Shanghai, noticed a lot of pollution, looked at his 2 young children, and said, I want to solve this problem. I'll start a car company. And that's ultimately where we came from. In China, we trade under the name Weilai. Weilai means blue sky future or blue sky coming. Our cars are sold under the Neo brand, and blue sky coming is our company motto, if you will. We think the future of mobility is smart, electric, autonomous vehicles, and we are working to lead the way in that space. So I'd like to tell you a little bit about 2 of our vehicles, and then go into the details of the autonomous cloud that I'm building with my team in San Jose, and what we're doing with that platform to collect this data, process it, and how we built all of this technology in this data center based on a container-first, container-native approach. So the first car I want to tell you about is the Neo EP9. This is a high-performance supercar. We have sold a handful of these vehicles. They have a extreme performance level. They'll do 0 to 60 in 2.1 seconds, 0 to 120 miles per hour in 7.1 seconds. And they put down effectively 1 megawatt of power into the drivetrain, which in old money is about 1341 brake horsepower. Back in 2017, just after I joined the company, an EP9 set a lap record for the fastest production car at the Nuremberg Ring in Germany, bringing the lap time down to 6 minutes 45 seconds. We have been eclipsed. We've been trading off with another manufacturer since then, but we're still up there certainly in the top 2. The EP9 retails for $1.48 million. It's not a car for the masses. However, last July, we started shipping our first consumer vehicle, the ES8. The ES8 is a 7-seater SUV, puts down 650 brake horsepower, and provides what we refer to in the industry as level 2 autonomy or ADAS functionality. And I'll talk about that in a minute. Since starting shipping the ESA in July, the number of units shipped up until the end of March this year is just over 15,000 units. So we started to get a bit of traction. We are focused initially on selling these vehicles in the China market, and that's because we're a startup. We're not large enough yet to sell cars globally, so we made a very conscious decision of looking at the global EV market, which in 2018 globally, close to 2 million EVs were sold total. 1 million of those were sold in mainland China. The rest of the globe was the other 900,000. So by focusing on the China market, we can establish ourselves, get a slice out of the biggest single region, and then expand over time. I mentioned I'd tell you a little bit about L2 ADAS functionality. And that's simply the type of driver affordances that you get from a luxury car today. So a Tesla Model X, Model S, a high-end BMW will give you features like adaptive cruise control, lane departure warning, lane keeping assist. In the automotive industry, this is L2 autonomy. There are 5 levels. L1 is dumb car with no functionality. L2 is lane keeping assist, autopilot. Level 3 is hands off the controls, but eyes on the road. Driver is ready to take over at a moment's notice. I wouldn't recommend an L3 vehicle. An L4 vehicle is hands off the controls, eyes off the road. And the vehicle will give you a few minutes of warning to disengage with your activities, pay attention to your surroundings, and take over. L4 is where most of the industry is heading towards, and it's what most people talk about when they think about autonomous vehicles. So to get to L4 is a massive software development effort, a massive data collection effort. And so what I'm doing in my team is building the data center and infrastructure that is used to do that data collection, to develop that L4 technology. So I'm building a autonomous cloud, and I'm building this on-prem. And I want to take a bit of a sidebar here and talk about the word cloud, because cloud is really one of the most misunderstood terms in the industry. Cloud is a collection of characteristics in the system that you're building. It's things like multi-tenancy and over-provisioning and ephemeral. But the really key characteristic, and the main characteristic, is self-service. The individuals using the resources are the ones who provision the resource. They don't have to open a service ticket and then wait for IT to give them the machine or give them the resources. The developer should go to a portal, click something, and get the resources straight away. So ultimately, with this formulation, the opposite of cloud is not on-prem. The opposite of cloud is full service, as in a full service gas station, where the attendant provisions you with gasoline, checks your fluids, and sends you on your way. That's not what we're doing. We're building a on-prem self-service cloud. And the workload on this cloud is about data analytics and machine learning. We strap sensors to vehicles, we drive them around, we collect a whole lot of data. We offload that data into our data center, and then our data scientists and software engineers iterate on the algorithm development using that data, and then we rinse and repeat. Our R&D vehicles collect about 15 terabytes of data per hour of operation. We have a small fleet of a couple of dozen vehicles, and each vehicle, assuming a 16 hours a day of driving in 2 shifts, will collect about 250 terabytes of data. That means that in my small fleet, I'm collecting about half a petabyte of data a week. There's no way I can push half a petabyte of data from my office to a hosted cloud provider in any reasonable time frame. I have some operational goals of having a maximum of an hour between data arriving back at the office and my data scientists being able to access that critical data. I can bankrupt a small country by trying to upload the data to AWS to meet that need. This platform that we built, we've only deployed a fraction of our target goal. We expect to have 120 petabytes of data under management for each vehicle model that we are developing. Right now, we've been working on this project for about 2.5 years. I've deployed maybe 5% of my target compute resources. And in the US, in our colo facility, 5% of my target means I have 13,000 CPU cores under my container orchestration environment. And in Shanghai, I have another 6,000 cores or so. It's an interesting question about why I'm using containers, because I was starting this project 2.5 years ago. Container technology was new, it was interesting, it wasn't fully baked. But it was pretty clear where the industry was going. And so I made a conscious decision with myself and the other engineer. I had one engineer on the project at the time. And we decided that if we were building a new greenfield deployment, if we started with VM-based technology, we would be constructing legacy as we go, because there was no way that VMs were going to be the long-term future of the industry. So instead, we decided to say, let's go with the cutting edge, let's deploy Kubernetes, let's deploy DCOS. We actually deploy them side by side, even though DCOS and Kubernetes provide arguably equivalent functionality. But at the time, it wasn't clear which one would win in the marketplace. DCOS was better for certain workloads, Kubernetes was better for other workloads. So we've been running them side by side and deploying the workloads that best suit those orchestrators to date. And as time has moved on, the workload we've deployed in each of those orchestrators has shifted and continues to shift. All of this really led us down to a space where container orchestration and container technology, it has been the most flexible, the easiest way to build out the kind of large-scale data processing that we need to run. But there are two major gaps in container orchestrators then and still today. That is networking and storage. The two areas where physics comes into IT systems. For storage, we selected a container storage integration from a vendor called Portworx, and that provides ephemeral storage underneath my container infrastructure, and I don't have to think about it. And for the networking side, I had very clear ideas about what I wanted for my container networking. I didn't want overlays. I didn't want underlays. I didn't want the IP address for my container or the IP addresses shown in my logs to change from the source of the flow down through the infrastructure to the destination of the flow. If the IP address changes, debugging and understanding logs was going to be a nightmare for my development team. So I looked around the industry, I looked at a number of SDN offerings at the time, and stumbled across Big Switch, and found that Big Switch was the only vendor who was even remotely ready to have a Kubernetes integration available. A developer had put together a POC, it was sitting on his desk. That was as advanced as the industry was for SDN integration with Kubernetes. So in 2016, October was my first meeting with Big Switch, and they told me about this POC they had. I thought, this is great. This is someone who actually knows how to pronounce the word Kubernetes. We had a conversation in January of 2017. I had an alpha version of that deployed in my data center. And in March of 2017, so about 4 or 5 months after the initial conversation, I partnered with Big Switch to bring that Kubernetes integration to GA functionality. And I had it deployed and running in production. I then deployed it in Shanghai. I've expanded my US deployment and moved from my office to a colo facility in the US. And throughout all of this change and all of this migration, I haven't had to think about my SDN. It's just worked. It's just being there, ticking away, allocating IPs, managing my connections between each container in my cluster, and hosting workloads that I run regularly, such as if someone goes out and drives and collects an hour of data, I have an ingestion workload that slices that data up from video files into individual frames, indexes that data, and then stores it in my data lake so that my analysts can run over it. One step in that ingestion pipeline launches 1,000 processes spread over an arbitrary number of machines and executes those 1,000 cores for about an hour for every 30 minutes of data collection that we collect. So it's about a 2-to-1 ratio. We launch that workload and tear it down every single day. And it just hums along flawlessly.
No, one close question.
You always have a question.
I do. Would you recommend going down the container path now compared to 3 years ago?
I would, going down a container path now is a lot easier because my team had to invent a lot of container cluster management tooling. That space has advanced a lot, and so there's a lot of vendors out there who will give you a Kubernetes distro. I would be very cautious, however, to make sure that you are not going down a path of running containers in a VM on bare metal. Because all you're doing at that point is getting the management overhead of a VM infrastructure, the management overhead of a container infrastructure, and they're not additive, they multiply. I'd recommend that you run containers the way they're meant to be run, on bare metal,
Okay.
with as transparent a network as you can put between them.
Makes sense. Thank you.
Thanks.
So as we switch over here to our last speaker, Don is going to talk. And purposely, we put these two together, as I was saying in the beginning, because we heard from a very new transportation company building some incredible new cars, doing incredible things. In fact, you should go look at it on YouTube for videos. That one of those land speed races that they won was actually an autonomous vehicle by itself, breaking a land speed record going 160 miles an hour around the tracks. That's crazy to see. Now, you expect them to do some crazy innovative things, but the next speaker, Don, running one of the oldest railways in America, 150 years old, actually happens to be one of the most innovative companies in the country. In fact, they've won awards for that, and they actually operate their own drone fleet. They have their own police force. You have one of the largest IoT environments in the world. And how many IP addresses are moving at any given time?
Roughly 100,000.
Constantly moving around the country.
In motion, so that's...
Take it from there, Don. Thank you.
So I'm Don Schroer. I'm a Chief Network Architect for BNSF, and here to talk a little bit about railroading. So there we go. All right. So BNSF, one of the largest railroads in the United States. We have 32,500 some miles of track. We operate in the western 2/3 of the United States. Nowadays, we're part of Berkshire Hathaway. And so geographically, we've got to cover a lot of area, right? And I want to talk a little bit today about how we do that. So our business, we carry freight. That's our primary business. There is some passenger service in there, but our big business is hauling freight. And we do that, 150 years ago, we had people all over the country, and they would actually be manually switching tracks and manually controlling trains. Today, that's all done via remote control. So we run our company out of Fort Worth, Texas right now. And the way we do that, today IoT is kind of a buzzword, right? We've been doing IoT since the 1940s, really. It's out of our network environment and IP address space, less than 10% of our IP addresses are users. Most of our environment are things. And, years ago when I started, I've been with the company 25 years now. We did a lot of analog things and a lot of circuit things. I started out as a DAX engineer, if anybody remembers what a DAX engineer is, and then moved into ATM networking, if anybody remembers that. So I've been around a while. So, but we used a lot of those technologies because they were the technologies of the day, right? In about 2007, we decided it was time to go to an all IP world. And that really meant big changes for us. When you get out in rural America, analog circuits are prevalent. And to this day, we have places where we're getting, even getting TDM is hard, getting IP is really difficult from carriers. So we've had to build a lot of that environment ourselves. And in doing that, so we have 17,000 miles of microwave path in the US, because where we need communications are generally locations where there are not people. And so we need communications, and we need reliable communications to get to those locations. So we started this project and really kind of started converting everything to IP. And that meant a lot of development, right? Taking things, and rather than taking things that over the years were manual, that had been adapted to analog, that had been adapted to TDM, that rather than take that and adapt once again to IP, for the most part, we decided it was time for a clean slate and to really go to native IP devices. And devices for us, really, we wirelessly connect to 35,000 miles of track, right? And so we've been doing that. We use Wi-Fi, we use cell, but we also use a lot of proprietary or industry wireless protocols, low data rate protocols, using a lot of licensed radio frequencies, and cover the entire network that way. So another benefit to going with the wireless access, as most people know about, is it's easy to build redundancy into those kind of environments. So we have sites roughly 30 miles apart around the countryside, and then those sites are base stations that actually control track signals and track switches. And they're also sites, we have voice communications from our headquarters in Fort Worth to the entire railroad. So we have to be able to talk to train crews and maintenance crews and people out working alongside the track and make sure that we are, controlling safety, for instance. We can't have things running together, right? Bad things happen. So that, we built this entire network out. We use multiple MPLS providers. We use microwave, as I said, and a lot of radio in our world. So, and let's do. So, as we have progressed and we've got data now live from railroad tracks, we started developing many years ago now positive train control. And we were the first company that actually had a working solution that if a train crew were to overrun the limits of their authority to be on a track, we would, via our data center, stop that train, and the train crew can't override it. So we came up with a solution, and then there were a few more accidents that happened, and Congress turned around and mandated that solution upon us, right, as an industry. And so, but in doing that, the industry got together, and we now have a better solution than just the solution we had initially done. But as a train gets ready to leave a location, it downloads a database, it downloads information like what it weighs, for instance, and what the terrain is going to be that train is going over. And on board the locomotive, it has to calculate braking distance. So it's keeping track of where it is, it knows what the limits of its authorities are, and it's constantly watching braking distances. So if something happens that a train crew it doesn't understand where they're supposed to be, or anything else happens, we'll talk about sensors in a bit, automatically that train will go into braking and stop itself and prevent accidents from happening. So our data centers are a key part of that environment, right? So we control everything from Fort Worth, as I mentioned before. The data that runs all of this positive train control environment is back there in the data centers. We have servers that are keeping track of every train that's on our network, what that train's doing, what track it's on, where it is on the track, where other trains are on the track, where workers are on the track, where vehicles are, and it's calculating that all the time, so it can issue a control mechanism to the train to say, hey, you need to stop, or you have authority to go on, right? So our network and our data centers have become a much more critical part of our business as we move forward. So about 4 years ago, we started looking at data center refresh, and we had a traditional data center environment, and it worked okay, but we were starting to do a lot of things like network segmentation for security purposes. And what we were finding is our data center was becoming more and more and more complex all the time. So we started looking, number one, at a refresh cycle, but number two, at how do we do networking better than we were at the time. So thankfully, we had an opportunity, actually, so in our data centers, we have a variety of environments there. We've got a large ESX environment. And in fact, most of our servers are done that way. Now we have a new VxRail environment that we've been operating for about a year now, and testing that and learning about that and integrating that into our environment. We have bare metal servers running Cassandra, running Hadoop, and various other functions. We've got Nutanix, and now we've got OpenShift as our container platform that we run in our data centers. Via contracts, we have multiple different server management teams. So some of our servers are managed internally. Some of our servers are managed by other teams with other companies. Sometimes we contract with companies to bring a PaaS on site. And so we've got multiple management domains in our data centers, and mostly homegrown apps. I tell people you can go to Amazon.com right now and and search for railroad operation software, and there's nothing there for sale, right? So we have to write most of our software. We have 800 software developers on property, and then software teams overseas as well, so writing software for us. And one of the issues we have is we have multiple mainframes. And so we have a data gravity environment where going to the cloud means things don't work very well, because going to public cloud, because the primary data that most things are accessing are back in our mainframe environment, and which, by the way, is in Topeka, Kansas. So Topeka, Kansas isn't close to anybody's cloud, right? So it's we have our own data centers, and we will have our own data centers. And as we as we started looking at refreshing our data centers 4 years ago, we kind of established some goals that we were really looking for compared to the environment that we were on at the time. And the first one is that we believed that going to open networking hardware was in our favor. And I say that not just because of a cost factor, but open network hardware lets you control the refresh cycle. Where, nowadays, most vendors, if you buy a proprietary hardware package from a vendor, they sell you software licenses, and that software license is good for 1 year, right? Or 3 years, whatever your terms of agreement are. But what happens when they decide they think you need new hardware? They turn around and say, oh, well, yeah, you can't get a license for that switch anymore. So guess what? You need to buy a new one, right? So by going to open network hardware, we believe we control that cycle. And we refresh hardware when we think it's appropriate. So we believed that networking should be easier, that what we were building in our data centers was getting more complex by the day, and especially when we started doing network segmentation and routing traffic through firewalls and load balancers and back through firewalls to get back to the same segment. We were doing crazy things like that were making it very difficult to manage the network in our data center. So I mentioned multi-tenancy. We have multiple management teams in our data centers. So we needed a solution that we could identify and divide up roles and responsibilities and access to various platforms. I mentioned network segmentation. We believe that there had to be an easier way. The number of /30s that we had in our data centers was killing us. So we wanted an environment that we could use APIs to access and manage. We believe CLI is, while still prevalent today, but I think just like when I learned TL1 in a DAX, it's time. So we wanted a solution that was easy to upgrade. We had actually gotten to the point where we were afraid to do software network upgrades or network software upgrades in our data centers because the risk was too great. And automation was another big piece, right? So those were a lot of the keys that we were looking for. This is kind of the environment that we have today. So we talked to Big Switch and played with and went online and did their free online labs, and then we actually bought a lab environment from our incumbent network provider, and at the same time bought a lab environment from Big Switch. And with our incumbent provider, 4 of us went to school for a week, and then we brought their professional engineers on site, and in 1 week, we had not passed a single packet through their fabric. Conversely, we purposely bought a lab from Big Switch, did not invite them on site. We got their book, got the equipment, partnered with Dell, and stood up an environment, and 3 of us had it running, I would say, in 4 hours, just by reading the book. Having never done it before. So, you know, that was really an eye-opener for us. It's like, well, this is kind of how we think networking should be. So I mean, it was really that stark for us. We literally went and powered down the other vendors' equipment and put it in storage. So it's this solution worked so much better for us. And it actually has worked so well that we have accelerated our rate of change, trying to get everything in all of our data centers onto this environment. We're not 100% there yet, but we're working rapidly to get everything moved to this environment. It's very easy. So one of the things that happened is, as they were setting goals for our network team for this year, our leadership said, yeah, we need to really get more stuff on our big switch production environment. And my boss said, well, what do you mean? And, oh, yeah, we need to really move forward with that. And she said, well, you realize like 80% of our data centers already moved, right? And our senior management said, what? Well, when did that happen? So it was a very, very slick, very easy thing to do. So where do we go from here? So I just briefly mentioned sensors, but we have sensors out there alongside the track, gathering data on various things. Most of them low data rate stuff, like a railroad switch, tick-tock, right? I don't need a lot of data for that. But we're moving into a world where we're gathering more and more data. So derailments, which are very expensive for us and can be very dangerous for the public, right? If you have a train with propane derail in the middle of downtown LA, right? Very, very concerning to people. So in order to try to prevent that from happening, for the last many years now, we've been deploying different sensor systems. Originally, we were really focused on bearings, wheel bearings in train cars. And so we have sensors out alongside the track that actually use infrared and measure bearing temperatures of a train going by at 70 miles an hour, looking for bearings that are getting hot. We have sensors that listen audibly to a train going by at 70 miles an hour, listening for squeaks in bearings. And we have draggers and various other sensors out there trying to capture data and trying to find things that are going bad mechanically before they become catastrophic. We're moving now into a new world where we're using artificial intelligence and analytics. One project that's really starting to gain notoriety is using video, high-speed video, taking pictures of wheels of trains going by at 70 miles an hour. We've got a test environment that's been up since October. Right now, it's been taking pictures of 750,000 wheels per day since October, and performing analytics and looking for cracks and hairline fractures in steel that wouldn't normally be visible. So 750,000 images a day, and since October, we've actually found 30 bad wheels that could have caused a catastrophic accident. So massive amounts of data. We're doing a lot of that processing. We think Edge is going to be a big investment for us because we're doing a lot of that processing on site, right? As you talked, when you start processing video and huge amounts of data, sending that across the network is really hard to do, right? So that project is going on. You mentioned drones. BNSF was the first company in the United States to actually be able to legally fly non-line of sight drones. We're using those to augment track inspection, looking for buckles because of heat or cold, that something that happens in our environment, trying to get better at that. We're also using drones. You know, we have bridges all over the United States, and sometimes they're 100 foot high, and we have to hang a guy over the side in a bucket truck to do a bridge inspection, right? Well, nowadays with a drone, we can do a lot of video and high def and not have somebody precariously hanging over the side of a bridge, right? So we're moving into automation. So this is one of our cranes, and today there's a person that takes those containers on and off that train and moves them around and puts them on a truck and things like that. And right now we're partnering with some companies that are going to automate that entire environment and get the people out of there. So, because it is a rather dangerous environment. The railroad, we work every day on safety, but it's very unforgiving, right? So when a 70,000 pound container falls on you, that's not good. So, and again, I think I mentioned the wheels. We go through a massive number of wheels a year, and so using analytics is helping us spot defects in that, and we're also doing the other side of that is the rail itself. We're running autonomous vehicles down the rail and doing sensors, magnetic sensors, and things on the rail, looking for track that's going bad or maybe going bad before it actually breaks or before it causes problems. So I think that's.
So one last question though, because you mentioned this morning when we were prepping for this, the sensor data itself. How many images are you processing a day, and what does that gain you?
So that one sensor site is 750,000 images a day.
At one site across how many sites?
Well, so this is a trial project, but we have thousands of sensors out there, and so as that technology and the intelligence behind that technology proves out, we will be building those all over the place because they're.
What'd you glean out of the sensors so far? How's the project going?
Very well. I mean, it's producing amazing amounts of data that are actionable data. You know, not just volumetric data, but actual data. 750,000 images a day, and we found 30 bad in a 6-month time frame. So it takes a lot. So what that tells you is most things are good, right? But we need to really focus on catching those things that are bad because they're so catastrophic.
And those are the things that could have been problems in a rail car, crashing, collapsing.
Yeah, absolutely, the whole train, right? So very, very important stuff. So,
all right. Well, thank you, Don. As Don was mentioning, they play around with labs. Everybody can go up to our labs. It's hosted up on a cloud. You can go to labs.research.com and actually play with a mock network itself. Have a full environment and play around and see how easy it is yourself. But one thing I hope that came clear from these different messages here is open networking has proven to do a lot of benefits, not just for hyperscalers, but for real enterprises. And the approach of doing cloud networking means you have to take a different perspective. The cloud is a set of principles that allow you to do better data center designs. Right? So I want to thank our panelists for joining us and sharing their stories. Thank you again for being here, and have a good day.